Like a lot of other processes in your body, digestion is controlled largely by hormones. There are 5 major ones that we're going to talk about that control digestive activity in the stomach and in the small intestines. 4 of them, 4 of the 5 are produced by the duodenum. The 5th is produced by the stomach. So let's start with that one. Gastrin is produced by those G cells that we talked about in the last video in the gastric bits of the stomach. They are stimulated by presence of food in the stomach, right? Especially really high protein content food, and they secrete gastrin, and gastrin causes your stomach via this hormone to start producing gastric acids and enzymes like pepsin and, churning, increased gastric mobility. So gastrin produced by the stomach. Once food gets to the duodenum, the chyme really gets to the duodenum, your duodenum produces something called secretin. And secretin increases the secretion of bile from your liver and also increases your stomach motility. So it's a feedback mechanism. So food gets into small intestines and it says, yes, give me more of this. And it tells the stomach to really, really start cranking, right? But you don't want to overdo it. And so when more stuff, especially fats and carbohydrates, get into the duodenum, it starts to secrete a hormone called gastric inhibitory peptide, which does exactly what you think it would do. It inhibits the stomach activity. So I always picture, it's a really old show before all of our times, but I Love Lucy. There's that famous scene where they're like packaging up chocolates, and then the chocolates keep coming faster and faster, and they can't keep up with it, and they have to start like eating the chocolates and hiding them in the apron and all that stuff. Anyway, you can overwhelm the small intestines too. So as more and more food starts coming in, it wants to slow your stomach down. So gastric inhibitory peptide. The 4th is called cholecystokinin. And whenever you see cysto, it's probably going to refer to the gallbladder. Cysto or cystic, right? Like your cystic duct is the duct that comes from your gallbladder. So when you get, especially lipids, but chyme that arrives in your small intestines and your duodenum, you secrete cholecystokinin, which causes the gallbladder to squeeze and shoot extra bile into the duodenum. Right, so if you eat a slice of pizza, then you are going to secrete CCK once it gets to your small intestines, and that's going to increase pancreatic secretions, right, of enzymes, but also it's going to cause your gallbladder to squirt out that bile. And lastly, but not least importantly for sure, is something called a VIP, vasoactive intestinal peptide. This also does essentially what it sounds like it would do. It causes the vessels to become active in your intestines, vasoactive, right? And that's important, right? When you have food that hits your intestines, hits your duodenum, it means you are going to need to absorb a lot of that food into your blood. So you're going to need to pump extra blood into your intestines, and vasoactive intestinal peptide allows you to do that. So to review, food gets to the stomach. Your stomach's G cells secrete gastrin, which targets the stomach and causes it to increase its action. The juices it secretes, the muscular activity. Then that chyme leaves your stomach, gets to the small intestines, and initially, right, you are secreting secretin, which says, great, let's secrete some enzymes and crank up this activity. Eventually, you're going to secrete gastric inhibitory peptide that's going to slow the process down. So hold up stomach just a little bit at a time. You're also going to secrete CCK or cholecystokinin, which is going to cause your gallbladder to secrete bile. And both of these will increase your pancreatic enzymes. And you're also going to be secreting vasoactive intestinal peptide, which dilates those capillaries in the intestines so that more blood comes in there and is able to pick up all of those nutrients that you are absorbing. So those are the major hormones that control your digestive activity. But it's not just hormones, right? You have nervous involvement too. And the first phase of all this is called your cephalic phase. And the cephala means head, right? So this essentially means your brain. When you see a commercial for, pizza, and they pull that slice of pizza out, and that cheese like drags along the outside, and it looks so good. Or you see the Skyline commercial, right, in the three-ways sitting up there just steaming, and they put the 4-inch pile of cheese on top. I'm salivating right now thinking about it. That can cause your stomach to growl, right? That means it's getting your stomach going, cranking out gastric juices, getting it to move. So that's your cephalic phase, right? So you're even just thinking about this, or smelling it, or seeing it, or someone's describing it to you, but it has to do with your brain, right? The next phase is the gastric phase, which is when the presence causes you to secrete gastrin, and gastrin cranks up the stomach, right? So your stomach stretches, the chemical contents change in your stomach, and it causes waves of stomach contraction. It causes secretion of gastric juices, which include, pepsinogen, which include hydrochloric acid, things like that. And then the last bit, it's called the intestinal phase. And this has to do with the rest of those hormones that we talked about. Right? When the chyme enters the duodenum, you start cranking out secretin and cholecystokinin and vasoactive intestinal peptide, and also maybe some gastric inhibitory peptide. But you also, the stretching gets some nerves going, and you have what's called an enterogastric reflex, right? So entero means intestines, gastric means stomach. So this means when you have too much stretching of the small intestines, it is going to inhibit gastrin production and slow down the stomach. So this is a look at that intestinal phase. So we mentioned the gastrointestinal reflex. You also have a gastroenteric and gastroileal reflex. Essentially what this does is when food hits the stomach, in addition to those hormones we talked about, you also have nerve reflexes which cause the next area to move, right? So like gastroileal reflex, when you got food in your stomach, you open the ileocecal valve and you move stuff from the end of your small intestines here into your large intestines, so that you can reabsorb that water and then get rid of it. This again is why sometimes you wake up in the morning and you eat your egg and you drink your coffee, and then all of a sudden, right, you feel things moving in your intestines, and no, it's not your egg that is moving down there. It is yesterday's egg or dinner from the day before that, and you're moving it along to make way for your current breakfast. The last part of your digestive system is your large intestines, right? And so this is the main functions are reabsorbing water, right? Because you've been dumping water in your alimentary canal this whole time, right? Saliva, gastric juices, pancreatic juices, bile. That's a lot of water. You have to reabsorb it, a lot of it at least. It also allows you to do some absorbing of important vitamins, and most of this is because of bacteria. So cellulose, right, like a lot of vegetable matter, what we call fiber, that we can't break down with our own enzymes. We don't have enzymes to do it. Bacteria that live in our colon are able to break it down. So they'll break down a lot of that fiber, and they will release important vitamins that we will absorb, right? So we need those bacteria in order to get those vitamins. And there are three main parts of the large intestines, right? So your cecum, your colon, and your rectum. Most of it is colon, but all three of those are parts of the large intestines. The cecum is just this little pouch. It's just after the ileum. So there's a sphincter in between the end of the large intestines, the ileum, and the end of the small intestines, the ileum, and the beginning of the large intestines. And it's called the ileocecal valve, and it opens and closes to regulate movement of stuff into the large intestines. It's where we begin reabsorption and compaction. This is where the appendix hangs off, right? The appendix is, as we talked about before, a lymphoid organ. It's full of lymphoid nodules. And again, because we've been collecting a lot of bacteria, and that cecum is sort of it's a corner, and sometimes stuff can get stuck in corners. Bacteria accumulate there, and so it's good to have this. But that said, It's also at risk of becoming infected, which happens, from time to time. You guys probably know somebody that's had appendicitis if you haven't yourself, and then generally you have to have that removed. Your colon, the next part, has 4 main parts: ascending, transverse, descending, and sigmoid colon. Here we have the ileocecal valve, so ileum, ileocecal valve, cecum, appendix hanging off here. And then we have the ascending colon, transverse colon because it goes across, descending colon, sigmoid colon because it looks like an S kind of, and then the rectum is this last little bit. It's not part of the colon, right? So cecum, colon, rectum. And the rectum is where we store feces before we get rid of it, right? You also have a unique setup with your longitudinal muscle of the muscularis externa in that you can kind of see it on the outside, and it's this band called the tenea coli, right? The tenea coli. And it holds all of this taut. And if you have like a big tube that's soft and then you sort of hold it together a little closer than it could be, it's not stretched out all the way, you end up getting these sort of pouches on the side. And those are called haustra. You also have these omental appendices, these little fatty things that stick off of there. And then in your large intestines, after you've finished hopefully reabsorbing a lot of that water, you have these mass movements where you push everything through to the end of the large intestines, hopefully into the rectum, and where it stays until you get rid of it. Your large intestinal wall looks a lot different than your small intestinal wall. As you can see, it does not have villi at all, so not nearly as much surface area. It's smooth. You make a lot of mucus. It's lined with mucus because what's moving through becomes a lot more solid over time, and so it needs to be sort of lubricated, eased on through. Then you get to the rectum at the end, and the rectum is the pouch that holds the feces until you're finished. Then you get to the anal canal, which is where the feces passes through on the way out. And because you're putting a lot of pressure there, you often can get veins that get distended, varicose veins, and varicose veins inside the anal canal are called hemorrhoids. The more you know. There are two sphincters at the end of the anal canal. One is the internal anal sphincter, one is the external. The internal is smooth muscle, and smooth muscle is not under voluntary control. So when the rectum distends, it relaxes because it's just a reflex, right? That just means, okay, it's time to go. Fortunately, we have a second anal sphincter that is the external anal sphincter that is skeletal muscle, which means we have conscious control over it, which means if our rectum and our internal anal sphincter are telling us it's time to go, our external anal sphincter can say, not yet, and it can allow us to hold it for a little while. If you'll recall, our throat, right, was the last time we had any voluntary control over this process, right? When we swallowed in our throat, we turned it over in the back of our throat and in our esophagus to our smooth muscle, and it's been under smooth muscle control until this part. So you can see the rectum up here, the anal canal. This on the inside is smooth muscle. This is your internal anal sphincter. This out here is your external anal sphincter that we have, thank goodness, for voluntary control. Again, large intestines is important for absorbing several vitamins, which we can only absorb if we have bacteria that break open cellulose. Its biggest job, though, is reabsorbing water. Right? About 1,500 mils of material enter the colon, and we absorb over a liter of water just through osmosis. And there's still about 200 mils of feces ejected at the end. It smells, largely because we have bacteria breaking down things and then releasing, things like hydrogen sulfide, which give that rotten egg smell, right? So this is a very generalized example of what you see. Defecation is a reflex, right? We have a short reflex, which literally is just stretching of the rectum, causes us to squeeze and open that internal anal sphincter, but the long reflex also tells our central nervous system that we have to go, and that allows us to hold on tight with that external anal sphincter.